Thank you for choosing to watch my presentation on applying MS Word automation techniques to generate reports more efficiently. I am Karen Harker, Collection Assessment Librarian for the University of North Texas Libraries, and I am presenting for NASIG Autumn 2025. I'll first start with an introduction of myself and my environment, as well as the learning objectives for this session. For this presentation, I'll describe our approach to automating assessment reports using Microsoft Word, Excel, and SQL Server. The goals of this were to streamline the reporting process, reduce manual effort, and improve consistency across reports. I hope that you will gain insights into the workflows, the tools used, and why we chose this solution. I'll begin with an overview of the context, including the role of our department with UNT accreditation reporting, setting the stage for understanding the challenges and solutions in report automation. By the end of this presentation, I hope you will be able to understand our workflow for automating assessment reports, at least to some extent. Evaluate various tools and methods considered during our development, and appreciate the benefits and limitations of the implemented solution. You should expect to leave with practical knowledge to replicate or at least adapt the process in your own environments. As head of the Collection Assessment Department at the University of North Texas Libraries, I manage a small team that gathers, organizes, and analyzes data to report on how well our collections meet the needs of our students and faculty. We have developed data-driven solutions for institutional reporting and assessment of the library's collections into a collections data repository that is centered on the concept of subject-based collections. With this repository, we have the ability to produce information that is specific to any academic or research need. I'm going to focus now on our responsibility to deliver reports to the university's accreditation office on the library's support of academic programs, called Academic Program Reviews. We had developed a reporting process for collection development purposes, that is, acquisitions and deselection, using a combination of Power BI and PowerPoint. This is very visually oriented, and it's relatively easy to produce once the data has been gathered. However, for academic program reviews, the output is expected to be more narrative and in a Word document format, which is much harder to automate and integrate with our current tools. Creating 10 to 12 reports each year specific to different academic programs requires a lot of tedious work. Our data structure is complicated, with data pipelines from numerous sources feeding into a central set of SQL Server databases that make up the collections data repository. These are raw data sets from which we generate aggregated statistics showing both relative comparisons and longitudinal trends. Here is a visual representation of our pipelines. The view on the left is that of the whole system, feeding into the collection map funnel and producing outputs such as reports. The view on the right is a close-up of one of those pipelines from our ILS, Sierra, into these databases. And here is a diagram of the collections data repository itself, with each block representing a database in our system. The lines indicate links between these blocks, notably with the collection map in the center linked directly or indirectly to each block in the set. Some of these are still being developed or at least dreamed about. One aspect of our department is our constant process improvement, notably through iterative development. In this case, automation of reports. The less we have to do for the routine work, the more time we have to work on the more challenging tasks. We had started a while back with typing in text that we got from other reports, such as Power BI. Then we started copying and pasting data from Excel into Word or from SQL Server into Excel. Then we implemented Power Query that directly imports data from SQL Server into Excel. We also copied and pasted tables from Excel into Word, but they always required additional finessing to adjust the formatting. After reviewing our current processes, I realized we still had way too many manual steps, from manually entering text and data to copying and pasting tables that still required editing. We still needed more direct connections between the data and the report. I'll briefly touch on the solutions we considered and describe what it is that we were really looking for. We considered several solutions during the development process, including Python with Jupyter Notebooks, Power BI combined with AI narrative writing tools, and Excel workbooks integrated with PowerPoint. The option we explored the most, though, was Power BI's paginated report, which, based on the introductory information that we had read, appeared to be what we needed. Unfortunately, it really wasn't the tool for our needs. It is meant to create reports that list items, such as for billing or inventory purposes, and not necessarily for producing multiple reports, complex narrative reports on different subjects. I kept returning to what could be considered a rather old technology, mail merge. Essentially, we needed a template that would plug in the values specific to each collection into the report. Now, we still need to write summary statements about these values, but such as relatively young and mostly print. But if we could at least get the values plugged into the word, that would save quite a bit of time and reduce the opportunity for errors. And mail merge has been doing this for decades. In fact, I could still recall the first word processor I learned back in the 80s, WordStar, which had this exact feature. Shows you my age. The chosen solution combines Microsoft Word, Excel, and SQL Server with object linking and mail merge functionalities. Word serves as the report template, allowing for customized text insertion via mail merge. Object linking enables us to embed an Excel table directly into the Word document. And Excel acts as an intermediate data source, storing both text and tables of aggregated statistics, while SQL still provides the original data source, calculating metrics from raw data in the CDR. This integrated approach ensures a seamless and semi-automated report generation process. Here's a diagram of our solution, showing how raw data from SQL Server are aggregated and generating statistics for each set of collections, which are then imported into an Excel file using Power Query. We created a Word template that uses mailings to merge data from the Excel file, as well as into Word-based tables. And we also used object linking to embed a table from Excel directly into the report. Next, I'll go over how we developed and implemented this solution. To develop the solution, we initially reviewed previous reports, identifying standard text, specific data elements, and summary statements that would need to be customized. We listed each data element, giving it a unique name and carefully documenting the exact calculation. This was used when we created the stored procedure to calculate these metrics and store them in a separate database table. This data was then imported into Excel using Power Query, with each row representing a collection to report on and columns for each data element. Finally, we created a Word report template, establishing the mailings linked to the Excel file, adding mail merge fields that corresponded to the columns in the Excel file into the narrative statements and the tables of the report, and highlighting text that would still need customization. We also added object links to tables from another Excel file, effectively embedding these tables directly into Excel, directly from Excel into the Word document. We then documented this whole entire process for reproducibility. Here are some views of the Excel file of aggregated statistics. Note how this is a very wide table, one row only for each collection to be reported on. We start with basic metadata about the collection, its name, the liaison, the programs it serves. Then we have statistics, each with its own column name, such as holdings num col, which represents the number of holdings in that collection. Note that some of these values are the same. These are library-wide or median values, such as the number of titles in the library's collections. These column names are then used as merge fields in the text of the template. Here is an example. In some places, it's just the name of the field, collection. But most of them, we have to use some sort of formatting because Word doesn't always bring in the values as expected. So we use something called number switches, which indicates how to display the numbers, or calculations such as multiplying by 100. The blue text is text that needs to be modified given the actual values in each report. This is a step that we are currently working on automating using AI. We can do the same thing with Word tables, utilizing Word formatting to ensure the values in the table appear correct and easy to read. Copying and pasting the tables from Excel, which is how we had been doing this, always required a certain amount of manual adjustments, adding to the work involved. I should note that the default output of a mailing or mail merge in Word is as a single long document. This was almost a deal breaker for me for this solution, given how time-consuming it would have been to split the output into separate files. I was able to find, however, a free add-in that solves this problem by saving each merged output as a separate file. You can set the folder in which to save the outputted files, and you can even incorporate data elements from the same Excel file used in the merging process in the naming of the set files, such as collection underscore APR underscore, and then APR year, such as anthropology APR to 2026. Running the merge and split function is actually pretty easy once all the fields are set up. Start from the Mailings ribbon, then select Merge and Split, which appears after you've downloaded and activated the add-in. The menu prompts for a file folder location and fields to use in the file names. The Split the Documents button activates Word Mailings, and within about 5 minutes, we had 10 to 12 separate document files ready for final editing. The final touch to automation was embedding tables into our documents. These tables are generated using a different Excel file, one that uses an algorithm to categorize the subjects of a collection based on a combination of factors. So here we have strong subjects, meets needs subjects, and subjects that need attention. While we could copy and paste the Excel table into Word, we realized that by doing that and pasting it as a linked table in the template, we could skip that step entirely and just refresh the table. Again, iterative automation. The hardest part was figuring this all out and creating the program that generated these statistics. Once we put it all together and documented the steps, generating the reports has been relatively easy. The academic program review process begins when we are notified of the programs to be assessed, which we then match with our collections. These collection names are entered into the APR table that is used to store the aggregated statistics along with the evaluation year. I review and revise as necessary the subject mappings of these collections based on the curriculum. When the collections are fully mapped to the subjects, we run a stored procedure that calculates the metrics and stores them into that APR table. We then use Power Query to refresh the Excel file that is linked to the mail merge, which pulls in metrics from SQL, after which we can then execute the merge and split in Word to generate separate reports. We review and edit each report, summarizing the insights and updating the object links for the embedded tables before saving the final document. This workflow ensures a structured and efficient report generation process. Now I'll cover how to make this work in your environments with or without SQL Server, as well as some benefits and limitations. We centralize our data storage using SQL Server, but this solution can be adapted to work without it. Excel Power Query can import data from various sources, including CSV or text files that have been exported from your own integrated library system. Other Excel files that you may have that you want to pull in together, or even a folder of files as long as they have a consistent structure. Or you may want to keep your own file of metrics that you manually update yourself. The key to successful implementation is maintaining consistency in the file naming, the field naming, and metric calculations. This flexibility allows institutions, even without SQL infrastructure, to adopt the automated reporting system. This is a semi-automated reporting system that does actually reduce the time, despite how complicated it looks. It does reduce the time to complete reports. It enhances consistency, and most important for us, it reduces errors. However, it did require a lot of substantial development time and still involves some manual customization. Future enhancements are to incorporate AI summarization methods, but that will require comprehensive metrics for effective comparisons. The evaluations log table, the APR table we produce, gives us the opportunity to see how metrics of collections change over time, as well as compare them against each other. I've provided here a few helpful resources to get you started. Finding useful resources, learning resources on word merging was difficult. Most, including Microsoft itself, only cover the most surface level instruction, essentially just following the wizard. And the examples were limited to, well, what you'd expect: envelopes and labels, maybe a form letter. If you are fortunate enough to have access to LinkedIn Learning, this course, Word, Mail Merge in Depth, will allow you to go deep into this process, including the formatting modifications. For a free service, this page from Aventix was better than most, providing more explanations and different scenarios. And then I did find this course from Udemy that could be useful, but I didn't use it. It costs $15, which may be worth the price for their section on field code rules alone. I purposefully did not include all of the detailed steps that we use because our solution is so customized to our environment. However, I would be glad to answer questions that you may have or help you address problems if you are interested in implementing this at your library. These slides will be available from the SCED site to download. Thank you again for watching this session, and I hope this has stimulated some interest or generated innovative ideas of your own.